Okay, so today we're going to solve the question that is care symbol in grammar. So let's read the question. What does the question says? We build a table of n rows, one index. So if you're given n, this means like 5, then it's 1, 2, 3, 4, 5. These are 5 rows. We start by writing 0 in first row. So we take 0 in first row. And now in every subsequent row we look at previous row and replace the occurrence of 0, like this in the it's the first row and this is second row, and we replace the occurrence of 0 with 0 1. So here comes a 0 and here comes a 1. Great. And each occurrence of 1 with 0. Now there is a twist. Each occurrence of 1 with 1 0. So this is it. So this will be 0 and 1 again, and this is the third row. So it looks pretty simple, right? This is the third row, this is the second row, this is the first row. Similarly, we can draw it out for fourth row. 0 and 1, 1 and 0, 1 and 0, 0 and 1, and this is the fourth row. And for example, n equals to 3. First row is 0, second row is 0 1, third row is 0 1 1 0. So we have satisfied this. Third row is 0 1 1 0. Third row is 0 1 1 0. Second row is 0 1, as it says. Well made. And given two integer n and k, return k index symbol and nth row of the table. So if you want to return third indexed from fourth row, so this is first, this is second, this is third. So this is going to be our answer. This is going to be our answer, right? Exactly. This is the rest of the question. What we need to do, and that's all. That's all. This is everything that we need to do. We have to return third number from the fourth row. So this is all we need to do here. Simple, simple as that. So how can we do this? How can we do this? Suppose like I have a, let's make one more. Let's make it. It's going to go a bit big, but we'll be able to understand 0 1. It's 1 actually, and this is 1 0, and this also goes for 1 0. I'm going to make it push it a little below 0 1. And this goes for 1 0. This goes for 0 1 because it's 0. This goes for 0 1 as well, and this goes for 1 0. So there's a fifth row. What were the elements that we got in fifth row? So this is 0 1 1 0. You're going to do a like set of 4. 1 0 0 1, 1 0 0 1, 1 0 0 1. Great. This is the second row that was completed. Second set. 1 0 0 1. Yes, 1 0 0 1. I want to say that this is 1 0 0 1. And fourth one is, so this is also the set that was completed. And last one 0 1 1 0. 0 1 1 0. So this is like we want to return n equals to 5 and k equals to 3. So we want to return third index, third index number, that we can say, uh, index in the nth rows, nth row, kth symbol in the nth row of n rows. Okay, there are fifth rows, 5 rows, and we have from fifth row we have to return the third symbol. So third is this one, index to index, third index. Yeah, so we can definitely return this, right? We can definitely return this, and that is all. That is all we need to do with this. Yeah, so that is what the question is about. Simple as that. One index symbol and a throw of table and rows. So yeah, we can just have a try run. Like if there is like we pass a zero, initially a zero is passed, and suppose there is like r n equals to 5 and k equals to 3. So we will be here, and we will go one step down on the basis like if r k is greater than cur by 2. And what is cur? Cur is actually 2 to the power n minus 1. 2 to the power n minus 1. Like 2, it's power of n minus 1, not 2 to the power n, then we subtract 1. This is cur. And we'll check if cur is greater than cur by 2. 2 to the power n is n minus 1 is 4 to the power 4. Uh, 2 to the power 4, yes. It's 16. If is 3 greater than 16? No, 3 is not greater than 16. No. So we will not go to the right side, we go to the left side, and we'll go to the left side if this is 0 already there. So we'll just add a 0. So now this is the subtree that we are at right now. This is the subtree that we are at right now, and like this is subtree, and from here we'll check if k is greater than cur by 2, and cur by 2 is 2 to the power n, that is 4 by 2 to the power 3, 8 upon 2, 8 upon, I guess I'm going it right, I guess I'm not wrong. It was by the way 8, it was by the way 8 here, it was cur by 2 is 8. So we'll check if 3 is greater than 4. No, it's not. Again we'll go to the left side of the tree. We'll go to the left side of the tree. So this is the tree here, and 0 is here, and which is 1 is here. So yeah, this is the left side of the tree. I guess I'm like not wrong, because this 1 here. Yeah, pretty good, pretty good. So we can do like we've done it 4, we've done it 3, and 2 to the power 3. Now you're at 3. So 2 to the power 3 is 8. 8, 8 minus 1 is 4. 4 divided by 2. 4 divided by 2 is 3 greater than 2. Yes, indeed it is. So we'll go this time on the right side. We'll go this. We'll go to this. We'll go to this. We were at here. We were here, but we will go, and if like 0, we'll go to the left side, right side. Uh, that is it. One thing I was giving some stress upon, like we need to go left or right. Let me tell you again. If it's 0, and we'll frame the condition for that. But right now, like what we need to do is because since it was k was less, k was greater than 2, Okay, then we need to go on the right side, and right side it's going to be 1. You're pretty evident because like previous was 0 and we're going on the right, so it's going to be 1. It's not going to be 0. So 1, great, we are at here, we are at here, and 2 to the now it's 2 to the power 2 is 2 minus 1 is 2 to the power 2 is 2, and over to 1, 1 3 is obviously greater than 1, which is obviously greater than 1. Then we'll go to the right, we will go to the left, this is the third element. So it successfully found third element, that is 1, and we can return it. So if we while we go down, we don't know the values, so we need to find them. So there are some logic like the logic can be, if we are at 0, right, and k is greater than 2, k is greater than divided by 2. So if we are as like if it is 0, then it's going to be 1, and if it is 1, then it's going to be 0. All right, if it is 1, the root value is 1, then it's going to be 0, and if it is 0, it's going to be 1. So this is what we've seen here. And if like k is less than ker by 2, k is less than ker by 2, and this is k here, so 0 will be 0 will remain to be 0, will come down and assign the root value 0, and if you are at 1, then you will come down and assign the value 1. So that's simple as that. So it's I think it's a bit messy now, but you understand, got the idea how things are working. We can just go and code this up. So let's come to the coding. It won't take long actually. Won't take long, yeah. So I don't know why LeetCode is not working right now. So maybe you're stuck or somewhat. Funny how LeetCode is already loaded. Wow. Yeah, so we have to LeetCode, and let me just erase this out and code this in front of you. So what happens is that if we can just make a function named return self.dfs and pass n, k, and 0, that is root value and whatever. Because now we can create our dfs. So we self n, k, root value. If n equals to 1, we're going to simply return the root value that we've already done the job. We need to go no more down further, and our curve will be equal to 2. Remember I told that it's going to be 2 to the power n minus 1. The power is n minus 1, not we want minus 1 after calculating the power. So k if k is greater than curve divided by 2, if k is greater than curve divided by 2, then we will root, our root value is going to be 0 if root value equals to 1, else they remain to be 0. Yeah, because that's what happens. 0 0 1, So if it's here 0, it becomes 1, and if you're 1, it becomes 0. Going to the right side of the tree, and then you go down, deep down, using TFS. Simple stuff working in the background. K minus squared divided by 2, and this is root val. Else what we are going to do, else root val equals to 0 if root val is 0, else it equals to 1, and we are going to return self.tfs and minus 1 k minus divided by 2. Okay, it's rock to val. Let's go by 2 here as well, which is the error. So we'll just pass k, because we don't need to make our value less than our k. It needs to be as equals. Okay, and else we need to do it one more error. Now it's accepted. So yeah, that was it. Thank you.